So this is going to be question number 12 on your Utexas. This was a special request from Mr. Marsh to make sure we cover this for anyone going to AP, for one. But it's the idea about angles. I'm not going to test you on like a ramp problem, but you need to understand what happens. This is a rare occasion. This is the non-vanilla. What if the friction is not, or what if the normal force is not equal to the weight? Okay? So that's what we're going to talk about real quick with this problem. All right? So normally, if we had this mass, normally I would just have, all right, well, the weight pulling down is equal to the normal force pushing back up, and the arrows are equal. And that's why we do, for all vanilla problems, force of friction is equal to mu mg. All right? But that's only in the rare, I guess not rare, that's only in the cases of the vanilla problems where something's sitting flat, nothing is pushing down on the book, nothing is pulling up on the book. But this is a problem where there is pushing or pulling. Okay? So we can't use this formula anymore. We have to go back to the true generic equation, and that is that force of friction is equal to mu, the coefficient of friction, times the normal force. Okay? And in this case, the normal force is not equal to the weight. All right? Okay. So first things first, let's just say, all right, I see a friction problem, so that means I need to do my what's happening. Net force is equal to force applied minus the force of friction. But this can only be in one direction. This can only be all parallel or all perpendicular. Okay? So the force applied that we're given here is not going to be it's not going to be plugged into the equation just as is. Okay, so the idea is I can't just put in my force of friction here is not going to be just mu mg, and my force applied, I can't just put in here my force, which is 91. Okay, so I have to look vertical and horizontal real quick and break it up. So here's a little bit of vector stuff. All right, so if we look in terms of, we could talk in terms of vertical or y, whatever letter you want to use. I will just say vertical here. So we could talk in terms of vertical. For that part, we're going to have the weight pushing down, which is 13 kilograms. And then we have the normal force. We got to figure out what that's going to be. Okay, so we need to figure out what our normal force is. So our normal force is going to be equal to the weight pulling down minus a little piece of the normal of that force applied, which will be in the y piece, pulling back up. So do you understand? The big thing I want you to understand is that because somebody's pulling up on that book, the table doesn't have to push as hard up. Okay? The friction it depends on how much the table has to push back up with. So there'll be less friction because I'm pulling up on the book. All right? So then my normal force, which is what we're looking for, is going to be equal to the 13 kilograms times gravity minus the force in the vertical piece. You know our rule of thumb in our quick and dirty for components vector things. If I need the vertical component of something and I'm given an angle, the vertical has to be sine. So this will be the force applied, which is, in my case, 91.1 times sine of my angle, which is 64 degrees. Okay? All right. I get that to be 45.5. So the normal force is going to be equal to 45.5. Okay? All right, so then I'd go to that was all vertical. Now I'd go over to the horizontal, go back to this equation up here. And I'd say, all right, my net force is going to be equal to my force applied. And in this case, that has to be in the X piece, because this is pulling at an angle. Only the X piece of this is going to pull horizontally. It's going to make it slide horizontally. Okay, so I'm going to say X minus friction, which is going to be mu times the normal force, which we just got over here. All right? So we're going to say, put in our equations, MA is equal to, this will be our cosine theta. So it'll be, I'll just subtract, I'll put this in as numbers. So 13 times acceleration is going to be equal to 91.1 times cosine of 64 minus my mu, which is 0.35, times my normal force, which is 45.5. All right? Okay. I know that's a lot of steps. I know this is something more than what we normally do. I want you to just notice this, and this is the key thing I want you to understand. I want you to see that when you pull something up, then the normal force would be less. It's no longer mass times gravity. I had to get this little piece, the little vertical piece, to know how much I was pulling up. Okay? The horizontal piece was what was being used to slide it along. So that's why I had to do sine and cosine theta stuff. All right? Those are the important things. You can work your way through the problem from there, and you can work it with your numbers, but I want to make sure at least you understand, hey, look, sometimes the normal force does change. Okay? Okay.